Hi, in this video we'll learn about why resistance drops as we go from a series circuit to a parallel circuit. So we'll first analyze this left circuit, and this left circuit is just a series circuit. We can use Ohm's law to find the current running through the circuit. So I is equal to V over R. In this case, V is 12 volts and R is 4 ohms. So the current running through the circuit is 3 amps. And now we have to set up a system on how to analyze both of these circuits. And the way we'll do that is we ask ourselves, what does this voltage source see between these 2 points? So imagine if there was an imaginary wall here, and this voltage source does not know what's on the other side of this imaginary wall. So the voltage source only knows that it's supplying 3 amps, and it wants to know what is the resistance on the other side. In this case, we could use Ohm's law and just reconfigure the equation to be R is equal to V over I, and the voltage is 12 volts and the current is 3 amps. So the voltage source will think that there is a 4 ohm resistor on the other side of this wall. And in this case, there is. So there's a 4 ohm series resistor. So we'll use this same reasoning, but analyze the right circuit. We know that there's 12 volts on these 2 branches, and there's 0 volts here because it's connected to ground. And how do we know that there are 12 volts on these 2 branches? The reason is because there is no voltage drop between here and here, as well as this point and all the way to this point. And the reason why there's no voltage drop is because there are no components. There can't be a voltage drop unless there is a component to drop the voltage over. Between here and here, it's just a perfectly conductive wire. So since we know that there is a 12 volt voltage drop across these 4 ohm resistors, we could just use Ohm's law. And 12 volts over 4 ohms will lead to 3 amps again. So across both of these branches, there's 3 amps running through it. And we'll analyze the system the same way that we did with the left circuit. We'll make these 2 points, and we'll ask ourselves, what does the voltage source see in terms of how much current it's applying? The voltage source will see that it's supplying 6 amps. So the voltage source will think that there is a 2 ohm resistance on the other side of this wall. And imagine if we couldn't see across this wall as well. We would also think that there is a 2 ohm series resistor on the other side of this wall because of the way that we calculated what resistance is. So this is also where the equation R total is equal to 1 over R1 plus 1 over R2 plus ... negative 1 comes from. This is the parallel total resistance equation. So imagine if we added another branch that also had a 4 ohm resistor. Because of the reasoning that there's also 12 volts up here and 0 volts down here, we know that there's 3 amps running through this as well. So the voltage source will instead see that there is 9 amps running through instead of 6 amps. So the voltage source will think that there is not 2 ohms, but instead 12 volts over 9 amps. It will think that there is 3 over 2 ohms on the other side. And if we plug it into this equation, you'll also get the same result. I hope this video clears up why resistance decreases as we move over from a series to a parallel configuration. Thank you.